Hello class. Today we plan to practice probabilities involving not and probabilities involving or. Not and or are both logic connectives that we have learned in chapter 2 and chapter 3. Not means negation, right, in chapter 3 when we learn logic. Or here is inclusive or. So A or B means either A or B or both. So let's go to MATLAB Math. We start the practice. Calculation problems, we are going to skip those. Okay, from number 5, question number 5. Because P of E plus P of not E equals 1, P of not E equals 1 minus P of E, and P of E equals 1 minus P of not E. So A and the complement of, so an event, so E here represents an event. Not E also represents an event. Not E represents the event that E does not occur. We call not E the complement of event E. When two events are complement of each other, then their probabilities add up to 1. If we know one probability, if we know the probability of one of them, then we can use the formula to find the probability of the other. Just use 1 to minus the probability of the given probability. Very important and basic. If two events are complement, then their probabilities add up to 1. If it is possible for the events A and B to occur simultaneously, then the formula to compute P of A or B is this formula. Here we have a concept, it's called mutually exclusive. When two events A and B are not possible to occur simultaneously, we say the two events are mutually exclusive. If they are possible, if it's possible for them to occur at the same time, then they are not mutually exclusive. If they are not mutually exclusive, we should use this formula to compute the probability of A or B. So this is called addition rule. Let me quickly introduce addition rule in probability. Addition rule is used to compute probability of A or B. And we have two formulas need to grasp. The first formula is P of A or B equals P of A plus P of B. Very straightforward and symmetric formula. But this formula is only true under the condition that A and B are mutually exclusive. Okay, if A and B are not mutually exclusive, then we have to use a longer version formula to compute the probability of A or B. It is probability of A plus probability of B minus probability of A and B. Okay, so I can explain quickly why do we have these two different formulas. The first case, when A and B are mutually exclusive, remember events are subsets of sample space. So A and B are mutually exclusive means A and B are disjoint. They have no common members. They have no common parts, no overlapping parts. So probability of A or B would be simply the sum of probability of A and the probability of B. And what if A and B have overlapping part like this? Regularly, like in general, mutually exclusive is a special case, but more general case, A and B possible have overlapping part, then we would have to use the longer version formula to compute that. I don't know if you remember this formula from chapter 2. Cardinal number of A or B is the cardinal number of A plus cardinal number of B minus cardinal number of A and B. Or just think about the area. The area of A or B, this region, equals the area of A plus area of B and minus the area of the overlapping part. Because we counted twice, we have to subtract one time. How about just write them down? Because it's very important for today's class. Two formulas to compute the probability of A or B. Whenever we need to find the probability of A or B, the first thing we need to do is to determine, are the two events mutually exclusive or not, right? If they are, then use the first formula. If they are not, then use the second formula. And that's it. Let's go back at my lab math. So that's the formula when A and B are not mutually exclusive. Again, mutually exclusive means it's not possible for them to occur at the same time. If the odds in favor of event E are A to B, then the probability of the event P of E is given by the formula A to B favor. Then the probability of P of E is given by the formula the odds favor event E is A to B. It will be this one. If the odds in favor of E are A to B, then the probability of the event P of E. Okay, so let me actually solve that on my note. Odds of favoring E. Odds of favoring E by the formula is P of E over P of not E, right? We use E bar to represent the not E. And P of not E is 1 minus P of E, right? And we know that odds is A over B, that is given, A to B. So we are going to solve this proportion to for P of E. So we solve the proportion, we are going to do the cross multiply. Then we have this way. Then we have A times 1 minus P of E equals B times P of E. And A minus A P of E equals B times P of E. And then we adding A times P of E on both sides. Cancel. And we have A equals, on the right side we have B times P of E plus A times P of E. And we can factor P of E out. And we have P of E times parentheses A plus B. And then on each side we divide by A plus B, divided by A plus B. Cancel. Then on the right hand side we have P of E isolated. And on the left hand side we have A over A plus B. So that's the answer I just choose, right? It's gonna take a little bit of algebra. Yeah, if you could, you can write down or take a screenshot. I believe you have a way to take a screenshot. Then later when you work on a problem, you know why. Yeah, why P of E is A over A plus B. Yeah, it takes a little bit of algebra work. Take a little bit of algebra work. So yeah, we should choose this one. You are dealt one card from a 52 card deck. Find the probability that you are not dealt a jack. So we are going to use the formula. Use 1 to minus the probability that you are dealt a jack. Okay. The probability that you are dealt a jack is 1 over 13 because jack is 13, right? Hold on. Yeah. No. Jack is 11. My bad. King is 13. Yeah. Jack is 11, so 1 over 13. We in total have 13 numbers. Jack is one of them. So the probability of getting a jack is 1 over 13. And the probability not getting a jack is 1 minus 1 over 13. And that gives us 12 over 13. 12 over 13. Again, let me clarify. I enter a lot of stuff in the cell, but I also remember to remove those. I enter the process in the cell to demonstrate the process. But for getting a point, you cannot leave those in. It's a robot, so you have to delete those. Type an integer or a fraction, simplify your answer. Okay. Next. So far so good, guys. If you watched my video, you should have some impression about the formulas. But basically, 3 formulas. The first one is for complement. If A and B are a complement, then the probabilities of them add up to 1. Second set of formula, addition rule. The third one is the odds. Yeah, odds of favoring E, odds of against E. The formula gives the definition. Question number 9. You are dealt one card from a 52 card deck. Find the probability that you are not dealt a heart. The probability that you are dealt a heart is 1 over 4. Because every deck has 4 suits. Hearts, diamonds, clubs, spades. Each suit has the equal chance to be dealt. So the probability that you are dealt a heart is 1 over 4. Then the probability you are not dealt a heart is going to be 1 over 3 over 4, right? 1 minus 1 over 4 is 3 over 4. 3 over 4. Yeah, don't forget to erase those. That's supposed to be something you write on your scratch paper. Yeah, let me know. Leave the message in chat if you have any questions, if anything's not very clear to you. Question number 10. You are dealt one card from a 52 card deck. Find the probability that you are not dealt a card with number from 3 to 9. You know, the more straightforward way to find that is to find the probability that you are dealt a card with number from 3 to 9. Yeah, be careful with the wording. It said from 3 to 9. That means it includes 3, also includes 9. This would be different from saying bigger than 3 and less than 9, right? And in that case, both 3 and 9 are excluded. But in this case, both 3 and 9 are included. So we have 13 numbers. Among the 13 numbers, how many of them are from 3 to 9? 3, 4, 5, 6, 7, 8, 9. 7. So the probability of dealt a card that is from 3 to 9 is 7 over 13. And use 1 to minus 7 over 13. Use 1 to minus 7 over 13. We have a 6 over 13. 6 over 13. Because we can write 1 here as 13 over 13, right? 13 over 13. When the two fractions have the same denominators, you can add or subtract. Keep the bottoms of the top. The answer is 6 over 13. Let's erase the part and submit 6 over 13. Oh, this is a lot. So when you see the table, okay, not really. Yeah, let's read the question. In 6-card poker, played with a standard 52-card deck, C652, were 20,358,520 different hands are possible. Yeah, so you have this many different hands are possible when you randomly select 6 cards from the deck. The probability of being dealt various hands is the number of different ways they can occur divided by the denominator. So that's the denominator. The total number of possible outcomes in the sample space. Kind of shown to the right is the number of ways a particular type of hand can occur and its associated probability. Find the probability of not being dealt this type of hand. Okay, so my first impression of this problem is gonna be a lot of work, but actually, once you finish reading the problem, all we need to do is what? All we need to do is use 1 to minus this guy. Use 1 to minus this probability. Okay? So this is the number of ways the hand can occur. Yeah, the corresponding probability is that. And we are looking for the probability of not being dealt this type of hand. So just use 1 to minus the probability. And even better, we are submitting the answer as a decimal. Okay, so this is what we do. Getting a calculator, all right? What I would do is firstly, use 1 to minus, I'm gonna use a parenthesis. I like to use parentheses. And in the parentheses, I enter 98, and then slash means divided by, so use it, yeah, divided by, and 20,358,520. Now be very careful. If you enter one number wrong, you have to fix it. Yeah, be very careful. 20,358,520. Close the parentheses. So I got a decimal 0.999951863. Do you have the same decimal? It's very large because this number is very small. If you think about, yeah, numerator is shy 100, denominator is 20 million. Yeah, so if we run it to that 6 decimal places, we're gonna have 9999999995, right? 0.999995. Yeah, let's see. Do you have the same thing? Yeah. Okay. Awesome. Perfect. Yeah. 9999995 to the 6 decimal places. We round it down because after 5 we have 1. Yeah, it looks complicated, but once you understand it, it's so simple. This probably is the same thing. 5-card poker. The ways to have the 5-card hands is C552. That is 2,598,968. That many. And the probability of being dealt various hands is the number of different ways they can occur divided by that number. Shown to the right is the number of ways a particular type of hand can occur and its associated probability. Find the probability of not being dealt this type of hand. Same way as earlier. Okay, use calculator. 1 minus left-handed parentheses, 8,764 divided by denominator 2,598,960. Excuse me. Close the parentheses. Yeah, I like to play with the TI-84 for calculator to learn how to speak its language. And you can enter exactly the expression you want in the calculator. You don't have to do multiple steps. Of course, that's not a mandate thing. You can process in different steps, use a calculator and scratch paper to assist you. And this one with 6 decimal places as well. So 0.996628. So we're going to round it up. 0.9966278. The A is bigger than 5, so round it up to 28. Right? This one, let's see. We have an age distribution of moviegoers. Yeah, for each age category, we have the frequency, the number of people who belong to the age group and they go to movies. Older people go to movies, younger people go to movies, right? Probably the 25 to 64, they are busy, not go to movies. The table shows the distribution by age of a random sample, 3,720 moviegoers, ages 12 to 74. If one moviegoer is randomly selected from the population, find the probability expressed as a simplified fraction that the moviegoer's age is less than 65. So all the first row, second row, third row, they are less than 55, right? How about, the two events, get a moviegoer less than 55 and then get a moviegoer not less than 55. One of them is easier to compute the probability for. In this case, compute the probability of getting a person, a moviegoer who is older than 65 is easier because it's the last row, right? So I'm gonna use the complement, use 1 to minus. Yeah, randomly selected person is older, yeah, not younger than 65, yeah, older, equal to or older than 65, and that's gonna be 1220 empirical, right? Yeah, 1220 all over the sample size 3,720. Okay, and since we need a simplified fraction, that takes a little bit of work. Let's try to use the calculator. Yeah, if you have TI-84 calculator, let's give it a try. Use 1 to minus left-handed parentheses 1220 divided by 3720, close the parentheses, equal, and you will have a decimal here, but don't worry. And then go to math, and then you will see the first thing, fraction, F-R-A-C, enter. Ooh, you get a simplified fraction, 125 divided by 186. Okay. Oh, my bad. I shouldn't have submit. I need to erase those stuff and then submit. Right. That's good now. My point here is, yesterday after class I assigned the worksheet assignment number 4 is about fractions, right? So you do need to understand fraction. The application of the technology to quickly get a result in fraction and simplified should not compromise your ability to handle fractions manually. But I also want to make your job easier, especially I want you to have a better score on a test. So this is an option, and nothing wrong to apply technology. So we want to do both. So this is the trick that you can use calculator to quickly get the result in fraction and simplified. Also, you need to do my homework, do my worksheet assignment, and show me that you know how to handle fractions. So that's that. Be very careful, okay? Because the test only have one attempt. Just now, I just didn't pay attention. Submit with the process, and the system will not identify that. Number 14. Number 14. This one. You randomly select one card from a 52 card deck. Find the probability of selecting an ace or a 3. Ace is number 1. 1 or 3, right? So this is a probability involving or. Remember earlier I said to apply addition rule to find the probability of A or B, the first thing we need to determine is, are the two events mutually exclusive or not? Let's consider, since you only pick one card from the 52 cards, is it possible for the one card to be an ace and number 3 at the same time? Yeah, I'm waiting for you to respond to my question this time. And you tell me, getting so we have two events here. Getting an ace, that's the first event, and getting a number 3, that's the second event. Are they mutually exclusive or not? Mutually exclusive means it's not possible for them to occur at the same time, since you only pick one card. And you tell me, are they mutually exclusive or not mutually exclusive? Let's see. Yes, not. Oh, I think they are mutually exclusive. Do we have different opinions? Different answers? So you only pick one card from the deck, right? Is it possible for the card to be both ace and 3? I think Natalia means not possible, right? Not possible means they are mutually exclusive. Yeah, they are mutually exclusive. It's not possible for them to occur simultaneously. Yeah, not possible. So they are mutually exclusive. Awesome, awesome, perfect. So we are the same. We are the same. Thank you, Lane. Thank you, Lauren. Because we can only pick one card. Yeah, exactly. So now we know they are mutually exclusive. So which formula we should apply? This one, the shorter version, right? The simpler version. Simply find the two probability and add them up. knowing that is the same experiment, okay? Knowing that's the same experiment. So the sample space contain 13 possible outcomes. Number 1, number 2, number 3, all the way to number 13. Yeah, we can see the sample space as a set containing those 13 numbers. Yeah, so this is how do I make it easier. Okay, I just type the denominator, one denominator. And then in the numerator, what's the probability of getting an ace? The 1 over 13, right? And what's the probability of getting a 3, number 3? One of the number contribute to that. So 1 plus 1 equals 2. 1 plus 1 equals 2. So we have 2 over 13. 2 over 13. Type an integer or a fraction, simplify your answer. So don't forget to clean that, only submit the answer. Is it very straightforward, right? Yeah, again, to find the probability of A or B, first thing to do is to determine, are they mutually exclusive? If they are mutually exclusive, then simply compute probability for each and then add them up. Okay, so this one, you randomly select one card from 52 cards. Find the probability of selecting a red 10 or a red jack. So or. Well, let's determine the first event, getting a red 10. The second event, getting a red jack. Jack is number 11. Are they mutually exclusive or not? Are they are they mutually exclusive or not? Huh? Are they mutually exclusive or not? You tell me, please type your answer. Tell me answer, they are mutually exclusive or they are not mutually exclusive. One of either of the sentence. Getting a red 10, getting a red jack. Are they mutually exclusive or not mutually exclusive? Yes, they are mutually exclusive. Yes, Liam. Correct. Yes, Natalia, they are mutually exclusive. Very good. Perfect. So you see, I do this again, right? So what I'm supposed to do is this. What the probability of getting a red 10 is 2 over 52 because we have 4 tens. We have 4 tens in total. 2 of them are red, 2 of them are black, right? So 2 over 52. And the probability of getting a red jack is the same thing. We have 4 jacks in total. 2 of them are red, 2 of them are black. So 2 over 52. And then I skipped this step. Do you see that? Since they always have the same denominator because the same sample space. So I keep the denominator, only add up the numerator. So that's what you see earlier. So we end up with 4 over 52. 4 over 52 simplifies 1 over 13. Sometimes I don't even have this step. I only have this step, like 2 plus 2 all over 52. Yeah, depends. Yeah. You can either way, as long as you're clear about the fraction, about the formula. Submit. A single 6-sided die is rolled. Find the probability of rolling an even number or a number less than 5. Okay, so it's about the or. 2 events. First event, get an even number, 2 or 4 or 6. Second event, getting a number less than 5, 1, 2, 3, 4. Question, since we are looking for the probability of or, right? Excuse me. We need to determine, are they mutually exclusive or not? Okay, you're going to tell me again. The first event, getting an even number. Second event, getting a number less than 5. Are they mutually exclusive or not? Yeah, you type they are mutually exclusive, or you type they are not mutually exclusive. They are not, exactly. Thank you, Natalia. Thank you, Lynn. They are not. Yeah, Lauren, perfect. They are not. So when they are not mutually exclusive, means they are able to occur simultaneously. We are going to use this formula, right? In the longer version. So let me show you how do I do that. The probability of the first event plus, let's do the probability of the first event. 6 die, so 6 side die. Get an even number, so 3. The probability of getting an even number is 3 over 6 plus the probability of getting a number less than 5. So 1, 2, 3, 4, 4 over 6. But not done yet. This is a longer version. Very, very important. Yeah, you're gonna write not mutually exclusive on a scratch paper to remind yourself. And you have one number to subtract. The one probability is gonna be the probability of getting an even number and a number less than 5. Okay, yeah, let me write it down. Getting an even number, let's say A is an even number, 2, 4, 6. B is getting a number less than 5, 1, 2, 3, 4. Then what is A and B? A and B would be 2 and 4, right? You see that? Yeah. A and B would be that subset, 2 and 4. So the probability of A and B would be 2 over 6. 2 over 6. So that is straightforward application of the formula, right? Or many times I do this. Oh, okay. So let's see if we have 1/3. Yeah, or many times I do this. I only use one denominator. And then I know in the numerator, I'm going to have 3 things, right? Yeah, 3 outcomes favor even number. Among the 6 outcomes, yeah, 3 outcomes favor even number. 4 favor the even, get a number less than 5. And minus, how many outcomes favor both even and less than 5? 2, right? Yeah. So my point here, sometimes I don't even have this part. I use that directly. This is easier, right? Just find a way that you feel more comfortable. So denominator is 6, numerator 3 plus 4 minus 2. 7 minus 2 is 5, right? Am I right? So 5 over 6 is the answer. 5 over 6 is already simplified. Yeah, 5 over 6. Awesome. Very good. Does that make sense? This is the first problem that the 2 events are not mutually exclusive. We'll see more. We'll see more. You are dealt 1 card from 52 card deck. Find the probability that you are dealt a diamond or a picture card. So the 2 events are, number 1, you get a diamond. Number 2, you get a picture card. Question, you can answer me again. Are the 2 events mutually exclusive or not? Mutually exclusive or not? Mutually exclusive or not? Getting diamond card, getting a picture card. Really? Diamond, do we have a picture card and also diamond? Are they able to happen simultaneously? They are not mutually exclusive, right? Yeah, they are not mutually exclusive. Yeah, thank you, Lord. No, they are not. Exactly. Because we are able to get a card, and the card is a picture card and diamond at the same time, right? So they are not mutually exclusive. So we know in the numerator, we're going to have 3 things. Okay, 3 things. First thing, among the 52 outcomes, how many of them favor diamond? Well, we have 4 suits. Yeah, 1 suit is diamond. 13 of them are diamond. So 13 plus. And how many among the 52 cards, how many of them are picture cards? We have 3 picture cards for each suit. 3 times 4, we have 12. And we have 12 picture cards, right? Yeah. So are you guys familiar with the poker? If you watch the video, you see the guided notes. You should get familiar with that. I also mentioned in the video, I get this from my students. I don't know how to do this problem because I don't even play poker. It's okay, but you learn, right? Nobody knows anything the very beginning. We all have a learning process. Yeah, let me finish this. Minus the third thing is minus how many outcomes among the 52 outcomes favor both. How many of them are diamond and picture cards? So diamond have 13, 1 all the way to 13, 11, 12, 13. So 3 of them are diamond picture cards. So that's the numerator, right? Do you see what I'm talking about? That's one way. Another way to get the problem done. So keep the denominator 52. Numerator, excuse me, 13 plus 12, 25. 25 minus 3, 22. So 22. And we're going to simplify, right? Simplify fraction. And 52 is not divisible by 11, so they only have GCF of 2. Divide 22 by 2, we have 11. Divide 52 by 2, we have 26, and that's the answer. Let's see, do you have the same answer? Yeah. So the answer is 11 over 26, right, guys? 11 over 26. Am I recording? Yeah, I'm recording. So if you have any doubt or you don't remember what we learned today, just go back the video. Go back the video. Next, spinner. It is equally probable that the pointer on the spinner shown will land on any one of the 8 regions, numbered 1 through 8. If the pointer lands on a borderline, spin again. Find the probability that the pointer will stop on an odd number or a number greater than 5. So here, sample space is 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah, sample space. Question, the 2 events. First event, get an odd number, 1, 3, 5, 7. Second event, get a number greater than 5, 6, 7, 8. Are they mutually exclusive or not? Are they mutually exclusive or not? Yeah, you need to answer this question. Think about, is it possible the pointer land on a region, the region is odd number and bigger than 5, you know? Odd number bigger than 5, is it possible? So are the 2 events mutually exclusive or not? Yeah, please respond. They are not perfect. Thank you, Lane. They are not mutually exclusive, all right? 7, right? Yeah, 7 is odd and bigger than 5. So this is what I do. Yeah, the sample space have 8 outcomes, possible outcomes. So I have in the denominator. Numerator, I know I'm gonna have 3 things. One number plus another number minus another number, right? Yeah. The first number is how many regions among the 8 regions favor odd? 4, right? 1, 3, 5, 7, 4. So that's the first number. Plus, second number, we need to figure out among the 8 regions, how many of them bigger than 5? 6, 7, 8. 3 of them bigger than 5, right? And then minus, yeah, the last number, we're going to minus the last number, third number. We need to figure out among the 8 regions, how many of them are odd and bigger than 5? Bigger than 5. So start from 6. 6 is not odd. 8 is not odd. 7 is odd. So one number only. Don't put a 7 there, okay? One number only favor both. So that's the numerator. Yeah, that I figure out that's the easier, shortest way to do this problem. Yeah, find the sample space and the number of the sample space size. The size of the sample space goes to denominator, and the numerator. Yeah, the number of outcomes favor the first event plus the number of outcomes favor the second event minus the number of outcomes favor both, and then you simplify. This way you don't have to operate a lot. All you need to do is to simply simplify the numerator. So numerator 4 plus 3 7, 7 minus 1 is 6, 6 over 8 is 3 over 4. Simplify is 3 over 4. Equals 3 over 4. Okay? And erase those. 3 over 4. Okay, so this one is empirical. When you see something like that, you know it's empirical, right? Male, female, high school only. not even high school, some college, and college or more, right? So let's see what are we looking for. Find the probability that a randomly selected person aged 25 and above, yeah, all of them are aged 25 or above, right? Yeah, so this is not about age, yeah. Has not completed the 4 years or more of college. Let me read it again. Has not, hold on, and age 25 or over, has not completed the 4 years or more of college. What? Let me read it again. Find the probability that a randomly selected person has not completed 4 years, has not completed 4 years of college or more of college, have not completed 4 years or more of college. So my understanding, this is a word problem. The total is 170 million, so we just do not talk about million. And numerator, the first event has not, so the person has not completed 4 years or has not completed 4 years of college or more of college. 4 or more of college. So I would say this column and or this column. Less than 4 years college. This is more of college. More of college. So I have 41 plus 40. And that's it, because the two columns, the two events are mutually exclusive. If the guy has not completed 4-year college, then this is not going to happen. If he already completed more than 4-year college, then this is not going to happen, right? So one or the other. Those are two categories. You should be able to see my big arrowhead. This or this, they are mutually exclusive. Let's see, give it a try. Simplified fraction, 81 over 170. 81 over 170. Only divisible by 3, 9. 170 is not divisible by 3. Should be like that. No. Mine is probably that occur using the formula. Okay, so this is about complement. Has not completed the 4 years. Oh, my bad. I guess this is an English understanding issue. So has not completed 4 years or more of college. So it's this column, this one, the last second column. So it's 1 minus 40 over 170. 40 over 170. There's a reason we need to practice, right? And that gives us 130 over 70. 130 over 170 is 13 over 17. Yeah, this is a, if they don't have these parentheses, I would understand it better, right? 4 year or more. This one doesn't have a parentheses. Not completed the 4 year, not, yeah, so the opposite, the complement would be completed 4 year or more. So this, all about this column, and then use 1 to minus. So 13 over 17. It's also empirical. We are looking for has completed the 4 years of high school only or is male. Okay, let's finish this question as the last question. Okay, these two events. So we are looking for a probability of or. The first event is get a person complete the 4 years high school only. So second column. Or we get a person, the person is male. So first row. And those two events are not mutually exclusive because male could complete 4-year high school only, right? So 170 is the denominator. Numerator gonna have three things. First thing, how many of them completed the 4 years of high school only? 50. Plus, how many of them are male? Male 82. Minus, how many of them are both? Yeah, male and high school only. Male and high school only. 24. And then we simplify the numerator. We might not, yeah, we didn't have time to do a lot of odds. So watch the video to look at the odds. It's just a ratio. Numerator 52 minus 24 gives us 26. 26 plus 82, 108. Let me double check. That is 108. And I'm going to use a calculator to simplify. 108 over 170. 108 divided by 170. And let's go to math and a fraction. I got a 54 over 85. 54 over, so only 2 as GCF. So GCF is 2, and this is 85. 85. And erase everything else. Okay, yeah, as I said, we don't have time to do the odds. We have 30 questions in this section. If you have any questions, just feel free to email me. And we're gonna stop here, and I'll see you tomorrow, guys. Okay? Thank you for coming. Have a good evening. Thank you, Lauren, for coming. Thank you, Liam.